Okay, class, we're back to topic 2D, deploying Ethernet cabling. Yay, my favorite. Okay. Exam objectives covered. The networking industry has developed a standard model for deploying a structured cabling system. The model is adaptable to both small and large networks. In this topic, you're going to learn how to distribute a system, how a distribution system can provision a network, and give that network access throughout a building or site. As you can see here, we have the telecommunications closet. Usually that closet's going to have your network rack, your modem, and everything else. Then, of course, we have the backbone cabling coming in. Let me actually share that for you guys. Give me a second. Just noticed I wasn't sharing my screen. As you can see here in the PowerPoint, you have your telecommunications closet, your horizontal cabling. The cabling comes into the building, and there's your backbone going down to the second story. There's your entrance to the facilities. Here's your modem demarc. And this is your ISP provider's cable coming in. So it looks like this is the first story down here. Up here, we have the second story. We have a telecommunications closet. We have a switch. That switch generally is going out to the work areas. Structured cabling system. Cabled network for client access in an office building will use a structured cabling scheme, such as the one set out in the ANSI TIA EIA 568 Commercial Building Telecommunications Wiring Standard. These guides identify the following subsystems within a structured cabling system. Work area, the space where user equipment is located and connected to the network, usually via a wall port. And they don't have an example of a wall port here. So that's what you'll see, a network jack, a network drop, and a modular wall plate. Most of the time they'll be remodel boxes. Horizontal cabling, which is what you see here. Horizontal cabling connects user work areas to the nearest horizontal cross connect. A cross connect can also be referred to as a distribution frame. Horizontal cabling is so called because it typically consists of cabling for a single floor, and so is made up of cables running horizontally through the walls or through the ducts or ceiling spaces. And most instances, if you have a building that doesn't have any crawl spaces or you can't get into the walls, because of the fact that it's already the sheetrock's already laid down, it's not a new development, you can run cable hiders, plastic molding. And of course, you'll see the horizontal up and down, left and right. Backbone cabling, which is this here, dark blue, connects horizontal cross connects, HCCs, to main cross connects, optionally via immediate cross connects. These can also be described as vertical cross connects because the backbone cabling is more likely to run up and down between floors, first, second, third, basement. I'm really hoping that we can get you guys into the Carlisle executive office so we can show you how those are actually ran out. Telecommunications room, or known as the network closet / telecommunications closet, houses horizontal cross connects. Essentially, this is a termination point for horizontal cabling along with a connection to the backbone cabling. In a lot of instances, you guys will have only a one-story facility. So the telecommunications closet, your modem, your demarc, and your access provider's cabling, all that will come into one closet. An equipment room is similar to a telecommunications room, but contains the main or intermediate cross connects. Equipment rooms are also likely to house complex equipment, such as switches, routers, and modems. Entrance facilities, demarc. It's this guy right here, the main modem. Special types of equipment rooms marking the point at which external cabling outside plant is joined to internal premises cabling. These are required to join the access provider's network for inter-building communications. The demarcation point is where the access provider's network terminates and the organization's networks begins. So this is generally where your ISP stops, and this is where your modem starts delegating information. In most instances, you'll have all this equipment in modern nowadays into a one network closet or one telecommunications closet. Cable management. This is essential, and not just network, but building systems, anything else. Remember that cable management is not only going to save you time, but if you manage your cables efficiently, you'll be able to identify exactly what cable it is. You'll be able to figure out exactly how to remove it, and you won't have to worry about bringing down the entire network to just remove one cable or replace it or redo a patch. Cable management techniques and tools ensure that cabling is reliable and easy to maintain. Copper wiring is terminated using a distribution frame or a punchdown block. A punchdown block comprises of a large number of insulation displacement connection IDC terminals. The IDC contains contacts that cut the insulation from the wire to hold it in place. This design allows large number of cables to be terminated within a small place. Several different punchdown block and IDC formats have been used for telecommunications and data cabling. A 66 block. A 66 block is an older style distribution frame used to terminate telephone cabling and legacy data applications pre-Cat 5. A 66 block comprises of 50 rows of 4 IDC terminals. The 25 pair cable from the access provider is terminated on one side from the block, and on the other side of the block, the terminals terminate the wiring from the PBX. A jumper bridge clip is installed over the middle 2 terminals to complete the connection. And I'm not sure if you guys have ever seen these. I don't have a picture of one. I can provide you one later. They usually look like giant panels. They're white, and you see these here up on top. And some of them get to be giant rectangular panels, and those are old PBX systems and old network systems. If you ever see anything like that and a client wants you to work on that, tell them that they're going to need a whole new setup. A 110 block developed by AT&T is a distribution frame supporting 100 megahertz operation, Cat 5 and better. A 110 wiring block is arranged horizontally rather than vertically, offering better density than a 66 block. There's also more space for labeling the connectors, and each column of connectors is color-coded, making management simpler. The incoming wire pairs are fed into channels on the wiring block, and then the connector block or wafer is installed to terminate the incoming connection wiring. Outgoing wire pairs are then punched into the terminals on the connector blocks to complete the circuit. And I don't think they have one of those. It should be that there. Here we go. The Bix and Chrome distribution frames, where a 110 block uses a two-piece design where wafer blocks are installed over the main block. You have blocks on top of a wafer block. Competing formats Bix and Chrome use a single module. 110 blocks and Bix blocks are developed by Nortel, are common in North America, while some European vendors prefer Chrome. As well as the differences in block design, the IDCs are angled differently in each format, requiring a different termination blade to be used to ensure a reliable connection. Now, most of these days, you won't see any of these things. What you're going to see is what we're going to discuss next is a patch panel and a patch bay. And this is standard for most networks nowadays. A patch panel, of course, you can see it here in the slide, all these Ethernet connections. Those are patch panels. Patch panels in data networks, numerous moves, adds, and changes max would require be terminating the wiring. To simplify, max, a patch panel or patch bay is a type of distribution block with IDCs on one side and pre-terminated RJ45 modular ports. These are the RJ45 modular ports on the front that you see. on the other. This allows incoming and outgoing connections to be reconfigured by changing the patch cable connections, which is simpler than re-terminating punch-down blocks. So if you look at the back of this punch-down, this is what you see. As you can see, it's one cable, got your stripy solid, stripy solid, stripy solid, stripy solid. And these here, if you take a look, let me see if I get to zoom in here. You take a look here. Can you guys see this, the A and B? This A and B is going to tell you exactly how to map out your port. So for instance, 17, if you wanted to go with A, you'd follow the diagram up here. If you want to go with B, you follow the diagram at the bottom. And you would just map it out. So here, you can see we have A. You got brown, stripy brown, blue, solid blue, stripy blue, and we're still dealing with A. See? Then we've got stripy green, or green, stripy green, orange, so on and so forth. And everything that you work with will have a diagram on it. Even these ports that go into the wall. Okay. Okay. The structured cabling running from the work area or forming a backbone is terminated at the back of the patch panel of the IDCs, which is back here. An RJ45 patch cord is then connected to the front port here for the patch panel, and then another to the network port. Typically, a switch port housed in the same rack greatly simplifies wiring connections is commonly installed. So in most situations, you'll have this patch panel, then you'll have a switch, and from the switch, you'll connect one connection to your router or your modem. So that modem will feed the connection into the switch. The switch will feed the patches as according to what you need. So for instance, if you have Bobby in office 5 and that office has a port that's labeled 5, you would take a small patch cable, connect it from the switch to port 5, and that would activate port 5 in his office. Then of course you can have Barbara saying, well, I need my internet activated in my office. Great, what's your port number? Port 40. Cool, we're going to take port 40, take a small patch cable, connect port 40 to the switch that's connected to the modem to enable access to the network. And of course, as you get into more intricate setups, you'll have firewalls, you'll have rules, you'll even have ports that you'll enable and disable in the firewall. That way you don't have to worry about Timmy coming in and connecting port 16 to the switch and just getting internet immediately for his Xbox. No, you'll have to enable the port that he connects into for 16. Wiring tools and techniques. Installing fixed cable from a bulk spool is referred to as pulling cable because the cable must be pulled carefully, meticulously, and measured from the telecommunications closet to the work area. Cable is normally routed through conduits or wall spaces, avoiding excess bends and proximity to electrical cables and fittings, such as fluorescent lights, as these could cause interference. Remember, you don't ever want to run data over power. You want to run them individually. That's also why in a lot of situations, like I was talking about with Nevada, Colorado, and a couple other states, you have to actually run conduit. And you run the conduit and you run the wire through the conduit. And if it's low level voltage, you run that conduit only for that wire. And if you have something that's high voltage, you run it in a separate conduit, ensuring that you don't have interference and that conduit shields everything that it needs to. Of course, the main fixed cable run can be up to 90 meters. That's about 300 feet. Stranded wire patch cords between PC and wall port and jumpers, a stranded wire cable without connectors used to cross connects, can be up to 5 meters, 16 feet, no more than 10 meters, 33 feet in overall height. This is because of attenuation or of the stranded cable is higher than a solid cable. So that's just generally telling you your main cable, if you're going to have one solid cable, is about 300 feet, right? If you're going stranded wire patch cords from the wall, your wall jack, to the computer, you want to do about, what does it say here? 16 feet and no more than 33 feet in overall length. So if you have someone that has a port that's on the other side of the office, but their desk is over here, make sure that that doesn't go over all 33 feet because of the different types of wires that we're using. A lot of people in the industry will go straight forward and just say, hey, you know what? I'm just going to use Cat 6E. That's, shielded enough and I can use that a lot, longer than most cables. Great. But if you're worried about overhead and making profit and ROI, you're going to have to actually use different cables for different situations. Starting at each patch panel, label the end of the cable with the appropriate jack ID and run it through the work area. This is also referred to as a drop or network drop, as in most cases you will be dropping the cable from the ceiling through the wall cavity or in between the sheetrock, and then, of course, running it through. If several cables are going through roughly through the same space, you can bundle them and pull them together. Leave enough slack at both ends, a service loop, to make a connection and to accommodate future reconnections or changes. Cut the cable and label the other end with the appropriate ID. Remember what I was saying about this morning's drop that I had to do for Megan at the Albuquerque location for campus. They had a cable. It was shoved too hard into the jack. The desk pushed it up. It bent the cable, crimped it. The cable was bad. And then, of course, the actual port, the network drop was bad. Thankfully, the individual followed the standard procedures of leaving some extra cable, a service loop, allowing me to be able to remove the initial drop, connect a new drop, and not have to worry about it being too short because there's not enough slack. Okay, so electrician scissors snips are designed for cutting copper wire and stripping insulation and cable jacks. Alternatively, there are dedicated cable stripper tools, and you can buy these at Home Depot or any of your local IT shops for like $5 to $6. But these cable stripper tools, they have replaceable blades and they have different cable data type sizes. There's one that you can actually adjust the size, and it'll say on it what size you need, and you can say, well, this is the Ethernet cable, and it'll actually help you remove the shielding from the Ethernet cable. Same thing for coaxial and other tools. Cable cutting blades should be rounded to preserve the wire geometry. Cable stripping tools should have the correct diameter to score a cable jacket without damaging the insulation wires. Heavy-duty cutters are required for armored cable. Now remember, I've seen a lot of people that strip a cable and they're like, oh, well, the orange wire, you could barely see the copper in it. Well, great. Cut that and restrip it and rerun it. If you see any break in that wire, that's going to cause issues. Just make sure that those wires are clean and that they're still shielded when you're terminating them and crimping them. Termination tools. Fixed cable is terminated using a punchdown tool. This tool fixes conductors into an IDC. There are different IDC formats, 66, 110, BIX, and Chrome. We discussed this. As these require different blades. Many punchdown tools have replaceable blades, though. Blades are double-sided. One side pushes the wire into the terminal, while the other side cuts the excess wire. Make sure the blade marked cut is oriented to cut the excess wire. That being said, what they mean is the blade that's marked cut, which is usually the longer blade, it looks like a fork. I wish I should have brought all this stuff. It looks like a fork, and one side's longer than the other. Make sure that the longer side is on the outside. That way it cuts that extra cable and it's not just flopping out of this little block that you see here. Alternatively, a block tool terminates a group of connectors in one action. For a 110 format panel, there are 4 position blocks suitable for terminating 4 paired data cabling and 5 position blocks for 25 paired telephony cable. A patch cord is created using a cable crimper. This tool fixes a plug to a cable and the tools are specific to a type of connector and cable. Though some may have modular dies to support a range of RJ type plugs, for shielded and screened cable, termination must be made to shielded IDCs or modular plugs. On an IDC, a metal clip is placed over the exposed foil or braided shielded bonds the cable to the housing. A shielded modular plug has a metal housing and is not terminated using a standard crimper. There are several different designs for crimpers, but all follow the principle of connecting the shield cable to a bonding strip. I'm not sure if they show you crimpers. You can get crimpers at Lowe's, Home Depot, Amazon, Newegg, or your local IT shop too. Gotta find a picture for you real fast. So this is a good example of a crimper. You also have Klein tools here. Some from Klein tools, I believe, have the tester themselves. And this is Home Depot. And they come in all various shapes and sizes. As you can see, this one has pass-through. And it gives you the actual pinout here itself. So that's extremely helpful, A, B. You have the stripper right there. That's extremely helpful. That's something you can pick up for 49 bucks. Of course, there's also kits at places like iFixit. We partner with iFixit at Daedalus and Intelitech. And we should be able to get you guys kits here soon, hopefully at a discounted rate. And these guys are wonderful for toolkits as well. And you guys can go through their website and see what you need to get as far as everything that you need. Okay, moving on. Fiber distribution panels and fusion splicing. This is fun. A modern build or refurbishment might replace copper wiring with fiber optic cabling. The structured links are installed in a similar way to copper cabling. However, because continually reconnecting fiber optic cables risks wear and tear and damage, and you do not want to replace the cable runs throughout the conduit, permanent cables are run through the conduit to wall ports at the client access end and a fiber distribution panel at the switch end. Fiber patch cables are used to complete the link from the wall port to the NIC. Remember, the NIC is a network integrated card. And from the patch panel to the switch port. Of course, we see here with the fiber optic cable. Using the connectors does not reduce overall performance of the cable. Each connector will cost a certain amount of insertion loss, typically budgeted as 5 decibels, well, half a decibel, and reflection loss. Consequently, in some circumstances, it may be preferable to splice two cables together, either to repair damage or to extend the cable run. Cables can be spliced mechanically using an adhesive junction box containing index matching fluid that ensures a continuous path between the two strands. A fusion splicer achieves a more permanent join with lower insertion loss at about 1/10 of a decibel. The fusion splicing machine performs a precise alignment between the two strands and then immediately permanently joins them together using an arc weld. A fusion splicer is a high precision instrument and must be kept clean and maintained following the manufacturer's guidelines. Remember that if you don't follow those guidelines, they won't honor your warranty or replace the unit for you. Splicing may also be used to attach a pigtail, a segment of cable with a factory-fitted connector at one end only, or to field terminate to a connector, splicing a factory-prepared SC or LC connector to an incoming cable. A spliced cable or pigtail must be protected with a special cover and supported by a splice tray. Connectors for field terminated splicing do not require a tray, and protective cover is built into the connector. Fortunately, we don't have any pictures of these, but this is where you see the fiber go into the switch. Transceivers. This is your transceiver. A network might involve the use of multiple types of cabling. When this occurs, switch and router equipment must be able to terminate different cable and connector types, and devices must convert from one media to another. Enterprise switches and routers are available with modular, hot swappable transceivers or media converters for different types of fiber optic patch cord connections. Historically, transceiver modules were based on gigabit interface converter, GBIC form factor, which use SC ports and was designed, as the name suggests, for gigabit Ethernet. GBIC was bulky and has largely been replaced by small form factor pluggable, also known as the mini GBIC. And that's that port that I was showing you guys on that Unify switch. It has an SFP port. You can purchase an SFP GBIC mini add-on, and it just slides right into that port, and it just becomes an accessible port that you can use for fiber optic. There's also some that you can purchase that enable rollover. So for instance, you have a client that says, I need 100% uptime. If Comcast goes down, I want you to be able to make sure I have another internet. Great. Well, let's get you CenturyLink or Verizon Cradlepoint with 5G, and the switch itself with this SFP will allow the switch to say, well, Comcast just went out, so let's switch over to the secondary service. And the minute that it notices Comcast or the main internet service provider come back up, it switches back over. And it sends you notifications as well. I get notifications on my phone for most of our clients when their internet goes down and it switches over to secondary internet. Okay, SFP uses LC connectors and are designed for gigabit Ethernet. Enhanced SFP, SFP Plus, is an updated specification to support full 10 gigabit Ethernet, but still uses the LC form factor. There are several different modules to support various Ethernet standards, and fiber mode type 10G base SR versus 10G base LR, for instance. Consequently, a transceiver is designed to support a specific wavelength. The transceivers must be installed as matched pairs. And then, of course, over here on the right, you'll see transceivers, 1 gigabit interface converter, SFP, 10 gigabit SFP plus, 4 times 1 gigabit quad small form factor, QSFP, and 4 times 10 gigabit would be a QSFP plus. And that's how you make the distinction for what you would need for those pluggable SFP GBICs. Okay. Let's see. Moving on. QSFP and QSFP plus, these last two down here. These are transceivers with form factors that support 4 times 1 gigabit per second links, typically aggregated to a single 4 gigabit channel. This is essentially, if you're familiar with Stripe RAID, this is what that basically is. You're taking 4 1 gigabit connections, bonding them, and turning it into a 4 gigabit channel. Enhanced quad form factor pluggable QSFP Plus is designed to support 40 gigabit Ethernet by provisioning 4 10 gigabit links. QSFP Plus is typically used with parallel fiber and multi-fiber push-on MPO termination. An MPO backbone ribbon cable bundles 12 or more strands with a single compact terminator. The cables are all manufactured and cannot be field terminated. So, for instance, you can't just go out and decide to splice these out in the field. When used with QSFP Plus, 4 strands transmit a full duplex. Remember, full and half. This means that it's a full 40 gigabit link. A half duplex would mean that it's a 20 gigabit link, but this is a full. These 4 strands receive, and all other 4 strands are unused. QSFP can also be used with wavelength division multiplexing, WDM, Ethernet standards. And we'll discuss that here next. Wavelength division multiplexing. Ordinary or gray SFP, SFP plus are duplex interfaces with one transmit port and one receive port that require two fiber strands. Each strand is in a single channel. The WDM, wavelength division multiplexing, is a means of using a strand to transmit and or receive more than one channel at a time. Bidirectional wavelength division multiplexing, BD, transceivers support, transmit, and receive signals over the same strand of fiber. So that's one strand of fiber. It doesn't require two. This uses WDM to transmit the TX and RX. You guys remember that? We had Halo basking. TX and RX signals over slightly shifted wavelengths, such as 110 for RX and 14.9 for transmission and 14.9D for receiving. BD transceivers must be installed in opposite pairs. Remember, opposite pairs. So the downstream transceiver would have to use 1490 for TX and 1310 for RX. You see that? How they're using opposite pairs like we were talking about with the cabling? They have to cross. Bidirectional wavelength division multiplexing links are documented in Ethernet standards, gigabit base BX, and 10 gigabit base BX. Okay, so we got dense wavelength. Now we're going to talk about coarse and dense wavelength division multiplexing. Coarse wavelength division multiplexing supports up to 16 wavelengths to implement 8 full duplex channels. Once again, is essentially like the theory of striping a RAID, or like we were discussing earlier, using a certain amount to complete full duplex channels of another amount. And in this case, we're using 16 wavelengths to complete 8 full duplex channels. Okay, this is typically used to deploy 4 or 8 bidirectional channels over a single fiber strand. Dense wavelength division multiplexing, or WDDM, provisions greater numbers of channels, usually 20, 40, 80, or 160 channels. That means there's much less spacing between each channel and requires more precise and expensive lasers. CWDM, coarse and dense wave division multiplexing transceivers support multi-channel 1G, 10G, and 4G Ethernet links. As with BIDI, that's bidirectional wavelength division multiplexing, the transceivers must be installed in opposite pairs for each channel. Okay, so as it was saying, if you have 1310 for TX and 1490 for RX, you have to flip those around and have RX at 1310 and TX at 1490. They have to be in opposite pairs. In a point-to-point VDM or WDM topology, each transceiver is cabled to a multiplexer, demultiplexer, MUX, demux. The single fiber strand is run to a MUX, demux at the other site. Alternatively, devices called optical add-drop multiplexers, OADM, can insert and remove signals for a particular wavelength channel on ring topology. Here we go, guys. You guys ready for some questions?
In this video, we'd like to demonstrate how to wire a patch panel. All right, so in order to basically wire your patch panel, what we need to do is on the back of the patch panel, we determine what the wiring scheme is, and typically what we're going to be using here is the 568A for the inside of the wall here. And what we need to do is we need to take these, and you can see that there is an arrangement here, and they let you know exactly how these have to get patched down or punched down with your punch down tool. And once you punch them in the right order, like we've already done here, we've actually got the patch panel itself wired. Now, what we need to do is we'll go ahead and we'll look at the other side of this cable, and on the other side of this cable we've gone ahead and we've wired the modular jack here, and it's kind of hard to see, but the modular jack actually has 802.11b and 568A and 568B, and what we need to ensure is that we have them wired the same way on both sides. Now, what we do from here is we're going to go ahead and we're going to take our little modular jack here, and we're just going to slip this in, and we'll push this down in, and it'll clip this down pretty hard, right? And now the other end of this little jack here is going to go into the faceplate on the wall jack. Now, we've gone ahead and we've already done that here, and you can see on the back side of this, we've got one wired, and that would run in the wall all the way to the back of the patch panel, and it gets punched down like this. Then from here, what we do is we just plug a cable in to our drop cable, and then this would plug into the back of the PC or the workstation, if you will. And then from here, we just attach a patch cable, and the patch cable then turns around and it gets patched down to the appropriate port. So in this case, we have this one right here wired, and we followed our labeling here as well. You'll notice that there's a 14 and a 15 here. The 15 is actually patched down, and you can see IT 115. Well, that's IT first floor port 15, and that's port 15 here on the wall plate, so that if we needed to patch it down to another location, we could identify on the front of the patch panel which drop cable or which patch cable has to be moved. And that's been a demonstration of wiring a patch panel.